again. So you can start. You can take a fresh start now. Now everything is ready. Over
Okay.
to you.
Okay, thank you. So hello everyone. Today we are going to start the new session, which is part of the Bootcamp 2021, that we are going to start the blockchain technologies, and specifically what we are going to do with the Ethereum and how we're going to develop dApps and different kind of applications with Ethereum. The Sajja will join us in a moment or in a while, but we'll continue our discussion from here. The important thing is what we are going to do is, as I mentioned, that our main focus will be the Ethereum and the dApp developments, application development. So we'll not be focusing mainly on how blockchain works, what the nitty-gritties behind the blockchain, how the details behind the blockchain. We'll not go into the complete detail of it. We'll discuss a bit what is blockchain and what the things are, and then we'll move towards the Ethereum application development, so that our main focus would be in practical coding of the application development in Ethereum. So before I start to say anything, anyone can contribute or say something about blockchain. What is blockchain? Anyone can have an idea or can say something about it.
Sir, blockchain is a decentralized distributed ledger.
Okay, blockchain is a decentralized distributed ledger, and
so it's immutable, and we can have two functions in it: only read and write. We cannot update or delete it. Anything.
Okay.
Like everything on blockchain is always permanent. And to use blockchain, we have to use money, real money, like Ether or some sort of cryptocurrency.
Right. Anyone else? Okay, so as Raza and I guess I forgot the name of the second person. They both have mentioned. That blockchain is a distributed database or a ledger which runs on multiple computers. It's not on a single system or a server. It runs on a multiple computers. They collectively calls network, and they come together to build a consensus whenever new information that we want to store on a blockchain. This is the one of the reason the blockchain is almost not impossible to hack, and it's one of the reason it's immutable, that whenever a new information is need to be stored on the blockchain, all the nodes develop a consensus. Once that consensus is being developed, then that information is allowed to be stored into that ledger or the database. Otherwise, that information will not be stored, or it will be discarded, or it will be lost. So the main important points, as the other person has also mentioned, it's distributed and it's an immutable, so you cannot update or change. So one of the reason, because you cannot go backward and do any change or update, that's why it's kind of impossible to hack, because we cannot allow them to change. And information in blockchain stores in kind of a block. So whenever we write something, we store something, or we do some transaction, everything we do which updates the block, which add the information in the blockchain, is called a transaction. So there are, whenever you do a transaction, it's whether you are storing information, you are transferring currency, or you're doing anything. Whenever you do the transaction, all the nodes on the network, let's say there are 1,000 nodes, so all those 1,000 nodes verify, validate, and try to execute that information. That's why it's not a single system which you can hack on, or on which you can fool a particular server or what, because there are thousands of nodes which are validating and verifying that information. Then that transaction, in case of if we talk about a specific implementation of a Bitcoin, in case of that, every 10 minutes they create a blockchain, a block. In that block there are multiple transactions, and for that block to be part of a blockchain, there need to be a puzzle to be solved, which is in simplicity, if we say that it needs to generate a hash code which is applicable, and then it can be stored into the database. So that puzzle needs to be solved. All the nodes try to solve that puzzle, and whoever wins that puzzle has the authority to write that information into the database, but all the nodes come together and verify and validate that information. So that's why it's quite scalable, not scalable in terms of because there are a lot of issues related to the scalability in Ethereum, but that's why it's uh, almost unhackable and quite interesting. And the world is moving towards this information set because of decentralization. There is no central system who someone can control or can block or can shut down, because there are many servers. One thing, in case one of its implementation is Bitcoin, one of the implementation of blockchain is Bitcoin. Generally, what we do is we intermingle, or we generally, whenever we start with the understanding the blockchain, we talk about the Bitcoin, and we think that blockchain is Bitcoin and Bitcoin is blockchain, which is not. Bitcoin is one of the implementation of blockchain, because blockchain starts with Bitcoin. That's why we think that Bitcoin is blockchain. So one of the implementation of blockchain is Bitcoin, and Bitcoin is only used to transfer the funds. So we can have we can transfer funds with each others. And another important point, it's a cross-border, borderless. Wherever in the world you are, you can transfer the funds with the single transaction, and there is no delays, or there is no intermediaries who are verifying or delaying or taking the commission out of it. There is no intermediaries, just the transaction you will do with one person to another. So blockchain, Bitcoin was one of the implementation, but the problem was with Bitcoin is that it's not programmable. It's just a currency, it's just a fund, and you can just transfer the funds with it. But the I'm forgetting the year, Vitalik Buterin come up with the idea that if we are using the blockchain to do the centralized to store the centralized information of funds, why don't we use this blockchain to store the applications or programs, so that it should be the thank you, someone saying it's 2014 or 15, but it's not 2014 or 15, it's quite earlier than. Okay, so what the idea is that we can develop an application on this centralized network or a distributed network, so that no single party can come and shut down the server. So there is no central someone is a central server, so if you shut down the central server, and everybody the server is lost. That's why the idea from the Vitalik was that we can create applications on the blockchain. Plus another point, if you want to issue your currency, if you want to develop your funds, your money, then what you have to do is you have to create your own blockchain. So if there is a Bitcoin, you wanted to do create your currency, then you have to set up a complete blockchain. You need to develop a community who runs your blockchain, and you need to manage the security and everything. So what Vitalik comes up with is the Ethereum network also supports to create your currency as well. So today, as we see the Ethereum, there are many other functionalities, but the main is that we can create a decentralized application on top of Ethereum. And if I want to issue my currency, my cryptocurrency, my token, so I can also create my token on the Ethereum, and it will all the nodes which are already running will be available for me to handle all those transactions and everything, and I don't have to worry about anything. Okay, so that's the because we are not going into the much detail into the blockchain and Ethereum, so we'll move towards the basic introduction. Is this, if anyone has a question, then we'll answer, and then we'll move to the what you say the coding part, or what the technicalities we need to handle.
Sir, I have a question.
Yes,
Sir,
please.
I want to ask that how the consensus is developed. For example, node 1 wants to update something, node 2 wants to update something, and there are hundreds and thousands of nodes, and hundreds and thousands of people are trying to update the system. then how consensus is developed?
Basically, what happened is, again, that's again we are going into the detail, but to answer your question, whenever we do a transaction, there are thousands of nodes. Whenever we do a transaction, that transaction go to every node, each and every node. So let's, for example, just when you do a transaction, it goes to the 4 or 5 nodes. I'm not specifying the number, but there is a number. These 4 nodes transfer that transaction to other 4 nodes, and that information goes to all the nodes. All those nodes verify that transaction and store at a place called transaction pool. So all nodes has a place called transaction pool, and in case of Bitcoin it's 10 minutes. In case of Ethereum it's 15 seconds. So every 15 seconds, what node does is, each node which is running on multiple computers, it picks the transactions from the transaction pool, and based on those transactions it tries to generate a puzzle, to try to solve a puzzle which matches a particular hash code. And that's the inner detail we are not going to touch. All those nodes try to generate that particular number which can generate a specific hash code. Once, maybe there are 2, 5 or 6 can generate it, but to keep it simple, in the ideal scenario, there will be a one node who will generate that number very first, or the first the only one who wins the race and generates that particular number. Now that particular node announced that I have generated the code, a number, and everyone stops the generating the puzzle, and that person will send that block, that information, to all the nodes. Then all the nodes will verify that yes, this number is correct, this information is correct, and it's validated. Once this is verified, then that node who wins the puzzle will be able to write that particular block into the database, or you can say blockchain. All other nodes who are generating the same block will discard this information, and that transaction set and that block will be stored into the database. Now the rest starts again, because 15 seconds are done. Now all the nodes will try to pick again transactions from the transaction pool and start generating the what you say, puzzle or a number. Then these things gets continued, and it will run continuously. So it's running on every what you say, every 15 seconds in case of Ethereum, and every 10 minutes in case of Bitcoin. It's up to the situation.
The question is, the purpose of using Ethereum platform is that if we develop a blockchain on Ethereum, so we would have available nodes, so that
Basically, we will not develop a blockchain. Ethereum is itself a blockchain. We will develop application on blockchain. So you imagine why blockchain is almost unhackable, and almost it has a community which is supporting, because it has thousands of nodes already running. People are already running those nodes, and there are minting going on many of the thousands of servers. So when you wanted to develop your own blockchain, you need those 1,000 servers for yourself, for your blockchain, for your currency. That's why Ethereum given us a platform, tool set, and everything, so that on staying on Ethereum, we develop an application on Ethereum. So whatever the transactions, whatever the currency we are developing, we are creating, that will be in Ethereum's blockchain. So Ethereum is managing the security, Ethereum is managing the community, Ethereum is managing. So that's an open source and an open community. So everything is managed already. So we don't have to actually, if you try to create your blockchain, then first you have to convince the people that use my blockchain. Why would someone do that? In case of Ethereum, they are for running the node, they are getting the transaction fees, they are getting the Ethereums for the proof of work. In case of Bitcoin, people are getting the Bitcoin for generating a block. So that's why what you need to do is you need to have a blockchain. and Ethereum solves it for us. So we'll instead of creating our own blockchain, everybody will not be able to do this. So we'll use it, and we'll try to develop application based on Ethereum instead of trying to create our own blockchain, which will be difficult for us. Yes.
That's great.
So basically, you explained proof of work
Yes.
in a very basic words.
Assalamu alaikum,
Would
sir.
the course
Sir,
Just a
मेरा-
moment.
course
Abid,
be in-
Ali is asking something. Just a moment, Abid. Yes, Ali Hussain.
So what basically my question is that if in the forward going forward in the course, we would be keeping in mind Ethereum 2.0 or the Ethereum, because there are many major architecture changes in Ethereum 2.0 as for the perspective of coding.
Basically, we'll be not talking the Ethereum 2.0, or from the technical perspective, coding perspective, we will not be working on Ethereum 2.0 because it's not there yet. We don't have the right tool set to implement. The mainnet is not there. Mainnet is on the Ethereum 1. So we'll be focusing on Ethereum 1. When 2 is completely available, then we can move on it, and we can write all the application at this moment on the Ethereum 1. So we'll focus on it. Yes, Abid said.
Assalamu alaikum, sir. My question is that Ethereum is an operating system for blockchains. When I studying, there are different kinds of operating systems, such as distributed operating system, network operating system. But Ethereum is a combination of distributed operating systems as well as network operating systems. May I right or wrong, sir?
Basically, these are the quite very technical words when you talk about. Whenever you talk about the networking, then you talk about these sort of things. It's a distributed operating system. Basically, what Ethereum is, it is an operating system. What Ethereum wants. Ethereum wants to be the world computer. Why?
Right.
So what they want is, they want everything to be running on Ethereum. So all the applications should be running on Ethereum. So you do not have to run your application on any other server or any other where. Ethereum will be there. All the nodes will be running Ethereum, and whenever you create your application, so you you use Ethereum and run your application on it. So world will be using it. It's an open source. There is no kind of a proprietary thing. That's why. So they're trying to create a world computer. So in a way, you can say it's an operating system for controlling the complete ecosystem of the blockchain. But definitely, it's not kind of a controlling of a monopoly. It's kind of a to have all the application on Ethereum.
Microservices, right, sir? Right. Thank you, sir.
Okay, Abdul Basit.
Assalamu alaikum, Zishan. Can I ask a question?
Angry Coder, yes, please.
Yes. So yeah, I understand you don't want to go into much detail of blockchain. Just want to ask one question quickly. So all these nodes that you were talking about, is it the people who are doing the mining with GPUs and ASIC miners? Is it the same thing?
Yes, basically yes.
Cool. Thanks very much.
Sir, I would like to ask one thing, that what makes Ethereum to take only 15 seconds to create a block, whereas Bitcoin is taking more than 10 minutes to create a block when they both are
It's the
working?
algorithm. It's the algorithm which they have written. The algorithm the Bitcoin has written took 10 minutes. Algorithm Ethereum has written took 15 seconds. So Bitcoin wants it to be more time taking. So it's less chance of for it to be hackable. That's why you see there are a lot of layer 2 applications like Polygon, Arbitrum, and Binance Chain, and there are many others. What they wanted to do is they wanted to reduce even this 15 seconds, and they wanted to have more transaction to be executed within 15 seconds. But the problem is, you wanted to have a security, you wanted to have a stable system which is available on multiple nodes, open source, everybody can use it, everybody can jump into it, and even you wanted to have a security. So that's why Bitcoin keeps it takes more longer time, so that if someone tries to, why this 10 minutes? Because if let's say there are 1,000 blocks at this moment, there are many, maybe 600,000-700,000 blocks, but to give you simple idea, if there are 1,000 blocks in the blockchain of a Bitcoin, you wanted to go and change the block number 5001. If it's so easy to change the block, so what you'll do, you change the block number 5001 and you then change all the other 5,000, because that's the property of blockchain, that if you change something in between, then you have to change everything. If maybe it takes milliseconds to change a block, then in few seconds you will change all the 10,000 blocks. But whenever you create a new block, it takes 10 minutes all the time. So if you change the block number 5001, then next 5,000 blocks multiply by 10 minutes. So you will lose the race, because others will already be adding more blocks. So that's why it's in a we can discuss in detail, but I'm not going to there, because it will take at least 2-3 hours to create a complete picture how this thing works. So I'll be avoiding this, but that's how the reason is that they have a built-in block algorithm which delays the processing of generating a one block.
Little clarity I would like to, I would want that Bitcoin and Ethereum, they both are working on proof of work. Yeah. So
Yes,
doesn't
yes.
it mean that their algorithm should be same?
No, every blockchain has its own algorithm. So Bitcoin, Ethereum might have taken all the things from the Bitcoin, but they have added a lot more things, and they have changed the algorithm, that how much time they wanted to take a block to generate. Okay, I
Sir,
guess let's move to. Let me just share my screen.
Mr. Zishan, I have one question also.
Yes, please.
All these servers, these nodes could be a part of multi-chain also, multi-blockchain. For example, some like one of my friend, he mentioned about the mining companies. So they have servers, they have nodes. Are these are the part of multi-blockchains also? The same
multi-blockchain is something different, and the mining servers is something different. Multi-blockchain basically cross-blockchain transaction. Whenever, if you have a Ethereum, if you have a Polygon, if you have Ethereum, if you have Solana, if you have a Binance Smart Chain, they are different blockchains. So to communicate between them, they are a completely separate blockchain. So this is the something multi-blockchain possibilities, but that's not. Yes.
Yes, sir. Yes, sir. Please.
So let's not go into this, because multi-blockchain is a completely separate concept, that how you two blockchain communicate or how they do it, because there is no direct possibility. So people try to do something else to create a coin of a different kind and send the transaction on that network. So that's the completely different area. The mining server is something different. Wherever you create a node of Ethereum and run on your machine, if your machine is quite powerful, you are running a big server, so that's the mining machine, and you can run thousands of nodes running on your warehouse. Data center.
Thank you so much.
Not warehouse, data center. Okay, so the repository we will be following is, if you see, github.com/Panacloud Modern Global Labs /DeFi Solidity Smart Contract. That's the URL we will be following, just for you guys to see. Okay, so we have created many steps, so we can follow one by one these steps and we'll start implementing. So what we'll try to do is we'll try to implement the try to run the smart contract on the Ethereum, and we'll learn how we'll be implementing or creating a smart contract and learning Solidity. So Solidity is important part, and the tool set which are important to run the Solidity applications and Ethereum applications. So so the very first step, definitely every language or every technology, when we start to learn, we need to have a hello world application. So that's the already created application. One more thing, what we'll do is we'll use Hardhat. Hardhat is a what you say, it's a framework or development environment which helps you to create Solidity Ethereum based application and deploy and run those applications. So because when you wanted to create a smart contract, it's not just a smart contract. You need to have a deployment, you need to have information, you need to debug, you need to run the task and everything. So for that you need to have some development environment. There is two development environment which is most common. One is the Truffle, which a beginner can use it, and there is an Hardhat, which is now it's not new guy, but previously it was new, and now big companies, big Ethereum blockchains, Ethereum dApps or applications are using. So there are many companies which are using it. You can go on Hardhat website, main website, and you can see the list of companies which are using AF, MyCrypto, Uniswap, 1inch. These are the big names: Open Zeppelin, Sushi, Genesis, ENS. So these are the big names which are using the Hardhat. So our target will be using Hardhat development environment. Of course, you can go directly on Remix and start developing your smart contract. So but the problem is, it's when you do with the Remix, it's you can use it for proof of work, proof of concept. So you can develop your concept, you can run a sample application, but then you must have to come to a development environment which gives you complete ecosystem of running an application, deploying an application. All those things needs to be there. So for that we'll be using Hardhat. Hardhat has many things which I'll show you. So what today we'll do is, today we'll try to get hand on Hardhat, so that we know how things are working, what is the folder structure, what is the architecture, what are the commands. So once we know all these things, then working on the Solidity contract code will be quite easy, because then we'll focus on Solidity and the code what we wanted to write. The architecture and the environment will be already set, and we'll be just running the commands and working on the contracts. Okay, so by following these steps is the very first step, in which what we're trying to do is we're trying to give you the basic understanding how you will set up the Hardhat, how you will create the development environment, and what the steps you need to follow. So for that, the repository is already there, but we'll try to run these steps one by one, so that, and it's our very first day. So I'll run all these steps and show you how the installation and everything is going on. But moving forward, will not focus time on the installation, and we'll try to just on the code. But today we'll do all these three steps so that you know what we need to do. Okay, so whenever you go to this page, this page gives you complete idea how you need to do installation, what are the tasks and everything. We'll do all these things one by one, and we have these steps here as well. So what I'm going to do is I'm going to create the folder, whatever you name it. Let me call it demo hello, and inside that I'll run the command prompt here. For when you try to set up for the very first time, what you need to do is you need to create npm init, and then you need to install Hardhat. So you need to install Hardhat in your folder. So what I'll do, npm init, it will just create the basic, ask the basic init questions, and it will create the package JSON file. It has nothing but just a package JSON file, which is
Sir, we are running the Solidity, but why we are npm? npm is not my package manager.
basically, and the packages available in the npm. So the packages, the Hardhat package is a Node.js package. So we'll be running the Node.js package, and then this package gives us all the functionality to run your application. So all the modules, all the blockchains have the modules available in npm, so like OpenZeppelin and all the functionality. Whenever the blockchain service wanted to give access to the developer, they give you the node module so that you can install it and use it in your application. So that's the package.json file. Now what we need to do is we need to call npm install.
So basically, Solidity doesn't have its own package manager, so it uses the JavaScript or Nodes one.
Solidity is a language. You see,
Yeah,
Solidity
but as we
is a
use
language.
Node.js
It
and
has its
JavaScript.
compiler. Let me complete. Solidity is a language. It has its compiler. When you compile it, they give you the bytecode. So I haven't gone into that detail as well, that when you, it's a compiled language, when you it's a source code, when you compile it, it generates the bytecode. That bytecodes go into the Ethereum virtual machine, and that virtual machine converts it into the machine language. So that's the steps that needs to be done. So whenever you compile the code of Solidity, you have that code, you can directly deploy that code through Etherscan or some other possibilities. So you don't have to go into all these steps, but that will not be the completely ideal environment, because we are developer, we need to have some files, some scripts, some this and that, all the complete architecture and folder structure needs to be there. We'll have 10-20 contracts, so we'll have to compile and then deploy them separately by going into the Etherscan directly. So that's why these development environments give us ease of use. So we have this development environment, you'll just call the deployment script and it will deploy your code to the Ethereum without going into the detail how to fetch the bytecode and ABI and then deploy to the Etherscan. So it will save us all those things. So npm install dev Hardhat. I should have run this command while answering you. Okay,
Yeah, the
so
node packages cost a lot of money.
Sir, I have a question. I'm very
yes.
good. I'm actually good with truffle. So also I'm using Hardhat, but I'm feeling trouble to use Hardhat compared to the truffle. So is it okay if I only use truffle?
Basically, there is no problem using if you are using truffle or if you are using remix or if you are using the Hardhat. It only matters when you wanted to work with someone who in a team or in for a customer, or if you're working and they want something in the team is already working on Hardhat, then what you will do? If you're trying to develop for yourself, you can do it, but what you need to consider is go to big projects like OpenZeppelin, Olympus, there are many others. They are using Hardhat, so there is some reason to use it. It's not just that Hardhat is if you like it or not like it, but there are many big companies, big names are using it. So there must be some reason. So, and the biggest reason is ease of use. I'll explain you because I have also used the truffle. So there are many things which you can easily do with the Hardhat, which were previously difficult with the truffle, and you are using the truffle, so you might have compare more easily. Okay, so it's installed. What we have to do is now we have to run npx Hardhat. Okay, so in the same folder, the demo hello, I have run the npx Hardhat. It gives us few projects: basic sample project, advanced with Typescript. I'll also show you, will show you the Typescript version. So at this moment, what we'll do is we'll focus on basic template. So we'll see the basic structure of the project. Yes, we wanted to name it. Yes, I wanted to add the git ignore. Okay, so now we have this basic code and we'll see what it's in it. Okay, so we have few files: readme, package.json, package log, Hardhat, config, test folder, script folder, node module definitely, and the contract. So starts with the contract. We'll at this moment we'll not discuss the details, but it's a contract. Its name is a greeter. It has a variable, a string variable. It has a constructor, a greet function, and set greet function. These are the few lines of code which is already written by the Hardhat for us. So that's the contract we have. Then we have a deployment script. What this script does is basically you call HRE ethers.get contract factory greeter. You get the reference of the contract. Then you call the greeter.deploy. I'll go into these details later. At this moment, I wanted to explain the structure. So whatever the constructor asks, you will provide here, and then you will call the deploy. So when you run this script, it will deploy your contract to the Ethereum or on the local net as well. Then we have a test folder. You can write test cases for your contracts as well, which is quite easy, provided by the Hardhat, because Hardhat integrated the Chai and Waffle test frameworks into their environment. So it's kind of a home, easily available to develop the test, to run the write the test cases. The get ignore file, the Hardhat config file is kind of a heart of this Hardhat development environment. So there is a task which, if you wanted to see the list of accounts, I'll explain what it is. And you are mentioning the compiler of your Solidity. So you are saying that my code will be compiled or should be compiled in 0.8.4 version of the Solidity. So you can specify any other version as well. Hardhat will compile your contract in that version. Of course, packages, and it has a few, and it's just have a Hardhat. So if you have these information, it will not do anything. If you see here, once I run the create basic app, it has given us the instruction that install these libraries. So I'll start the installation of these libraries. What these libraries will do is, if you can see, it's a Waffle, Chai, Ethers. Ethers is basically to communicate with blockchain. You previously you had one library called web3.js. Now you have another one which is ethers.js. And again, the more people are moving toward Hardhat and Ethers, so we'll be also focusing on the Ethers instead of Web3. Okay, now, so if you see this project, it has nothing but one contract, and you can add more contracts by yourself, which we'll do in a moment. And this script will run at this moment. This is in JavaScript. So what we'll try to do is we'll focus on TypeScript version of implementation. So we'll write Solidity code in the contract. We'll use the Solidity to run the scripts, create the scripts. We'll focus on the TypeScript. So at this moment, the basic example generates the JavaScript code. So that's why we are looking into this, and then we'll focus on. So why it's taking, okay. Okay, so once installation is done, what we will do is, installation is done, we'll call the npx Hardhat compile. Now what Hardhat compile will do? Hardhat compile will compile your Solidity code and generates its bytecode in ABI. Can anyone let me know or educate everyone that what is bytecode and what is ABI in context of Ethereum and Solidity?
Sir, I'm a little bit confused about the TypeScript and Solidity. Can you define when we are writing a contract in Solidity, why we need the TypeScript and why we need the TypeScript when we are using the Solidity? I'm a little bit confused.
Okay, no problem. The contract development coding for the Ethereum will be in Solidity, but you have the Solidity code. Now what you have to do is you have to run few tasks so that your code should deploy, and your code should be deployed to the Ethereum. You wanted to run few tasks, you wanted to test your application. For that you need some language. There can be any, maybe they might use PHP, maybe they might There can be any language, but because JavaScript and TypeScript is so common that they choose this language to help you to run tasks and every other thing that needs to be support your Solidity or Ethereum dApps will be done in TypeScript and JavaScript. So let's say, as I showed you, that this is the Solidity contract. Once we'll run the compiler task, it will compile it. Now what we need to do is we need to deploy it. So to deploy, if we are not using Hardhat, we have to manually copy the API and bytecode and go to the Etherscan or some other way where we can paste that code and deploy our code on Ethereum mainnet. Hardhat gives us the environment that you don't have to worry about anything. Just write the way you write up code. So what we'll do is we'll just writing ethers.get ether contract greeter, what is greeter? This is the greeter. And then it will give us the reference, and based on that reference we'll call the deploy. When we call the deploy, actually you see this is the constructor which is taking the string, and in that we'll call deploy and we'll pass the string. So this line will take the bytecode, will take the ABI, go to the Ethereum mainnet or the testnet, wherever you wanted to deploy, and it will deploy. It will give you the hassle-free deployment. You don't have to worry about anything. So Hardhat given us environment, and Hardhat given us the facility to run the code in JavaScript, TypeScript or JavaScript to deploy your code. It's not the Solidity. Solidity will be the smart contract to deployment and to support all other tasks for your application. We will be using the JavaScript and TypeScript,
Sir,
which is yes, please.
Basically, what I understand, this is basically a DevOps part of the DeFi app.
You can say that.
You
can say that. Yes, you can say that.
Thanks a lot.
Yeah, so you asked about.
But it's not
API
completely
and the
matching, but definitely will be using the side task. Yes, somebody is saying something.
Yeah, so you asked about ABI and the bytecode. So ABI is application binary interface. It is more of a structure of your contract that is used to access the contract from the front end part, and the bytecode is a semi-compiled program that is not totally compiled, but it is a very low level code.
It's compiled, but it's in the it's an intermediary language. It's a compile code. It's an intermediary language, and it will be converted into machine language with another compiler, which we call just-in-time compiler or the interpreter. We can name it anything, because at this moment I have skipped that part of EVM and everything. That's why I'm not technically trying to be correct on the specific part. Okay, so we have done the installation, we have everything, and now if you can see in this project, we have a contract file folder, we have script folder, we have test folder, and nothing else. Now what I'll do is, if you see, I don't know, what I'll do is I'll try to run this command, hardhat compile, npx hardhat compile. And we'll go to the, you see, compiling two files, 0.8.4 compilation finished. Now you can see we have two new folders. One is cache, and the artifacts. Cache will have the detail of your code, hash code, source name, your file name, what the content of your build folder is. All these details are here. The version you are using in your, so because these are the information that will be used by Hardhat, and it will help Hardhat to deploy code to the Ethereum network, testnet or mainnet. So we don't have to run, we don't have to learn into detail what this is doing. Now another one is contract folder, which you can see we have greeter.sol folder. In the contract folder we have greeter, so we have greeter.sol file. For greeter.sol we have a greeter.json file. In greeter.json file we have ABI. And in this API mention whatever our contract has. So it gives kind of an interface of our contract, so that whoever wanted to communicate with our contract will use this interface, and that client or that technology or that platform will know that how I can communicate. So you can see we have this for it says about the constructor. So we have a greetings, and you can see this one. There is no input, a name called greet, output it will return the string, state is view, and type is function. Now come to greeter.sol. So we have a greet function, its type is view, it's a function, it returns strings. Let's come back again and see this. So it gives the JSON interface in JSON format. So client applications, whether it's a JavaScript client or any other client that wanted to communicate with the blockchain, can use this interface. Another one, input is a string, name of the input is underscore greeting, function name is set greeting, state mutability, no non-payable, we'll talk about the payable and non-payable later, and type is function. So let's come over here. Set greeting, it has a greeting variable, it does not return anything, it does not have any view or pure keyword because it has the view keyword, and it does not return anything, it just update the variable. So you can see this is the ABI and this is the bytecode of our contract. So these information we don't need to go much into the detail, but you need to know that what they are and why they will be used and who will be using them. So we'll be not be using directly, even if when we'll be creating the client side. The good part of Hardhat is they gives us the Typescript types, so you can use those types directly, and it will be just like calling a function.
I have a question there.
Yes.
There was in the bottom of this ABI code, the deployed bytecode and bytecode is mentioned there. Is there any difference in both of them?
Yeah, basically once you deployed, they give you the, at this moment it is not deployed. So at this moment there'll be not much difference between them, but once it is deployed, there might be some changes which will be different from current and the deployed code. So you might compile after deployment, you might made some changes and you compile it again, so bytecode will change. See, that's why
Okay.
there's a difference. Okay, so now that's the two folders which is created by the Hardhat for us. And then once you compile it, we have two options. Either we run the test case to see if application is running properly or not, or we can deploy our code to the mainnet or something, or the testnet or somewhere. So for this example, we'll do both, but we'll not go for the testnet or something. I'll show you that later. NPX Hardhat test. So test is already there, and that test, what this test does is it's again create the contract. Now you see we have run we have created the contract in Solidity. Now I wanted to test that code. To test that code, how you can call a contract from a client side? You might be calling in client side. We might have a JavaScript client running in a browser. So JavaScript client will talk to the contract. So how it will be talking to the contract, that's what we are trying to do here. So in test, we create ether.get contract creator greeter.deploy, then deploy. Then we are trying to call the function greeter.greet. Now you are calling that function in JavaScript, not Solidity. So it gives you the feel how you will be calling your contract from browser-based application. So it will test the equals. Then you're calling greeter.set greeting. Sorry, greeter.set greeting. It will one more thing. Whenever you run a function which updates or change something in a blockchain, it is a transaction, and it will run the transaction. It will give you the transaction ID or transaction hash. You see, you have a transaction object here, We'll wait for it. I'll explain these wait and all these things later. We have many classes to discuss all these things. So I'll just run this. So what it will do is it will deploy, test the deployment, then run the greeter to see that it has a hello world, then update the content, and then see that if the updated content is here on made changes inside the contract or not. So npx hardhat test. It says successful. That means test is run. But to give you more specific feeling, what we will be doing to deploy it, npx hardhat run. We have this scripts folder. We'll call run script slash sample dash scripts.js. Now, whenever you run this, you have three options. I'm doing it with the
Sir,
first
it's
option.
sample script.js, not scripts.
Okay, thank you. Okay, so npx hardhat run script slash sample script.js. What it will do is, what Hardhat will do, Hardhat will create a local blockchain, run your code, and give you the output. This blockchain, this local blockchain, you will not have access to it as well. It will just run it and show you what happened. So if I run it, it will be exactly like when you will be deploying on a Ethereum testnet or main. Okay, it says deploying greeting, hello world Hardhat, greeter deployed to, and we have the contract address. Now, coming to the script file, what it does is it gets access to the factory contract, then it calls the deploy. Once it is deployed, we call greeter.deployed so that we wait for the deployment. Once the deployment is done, we try to access the contract. So everything in Ethereum, we have a two kind of address: externally owned account and the contract address. Can anyone explain me what these are?
Sir, externally owned accounts are at contract accounts, and and the other one is for the person who means a wallet address.
I guess
or,
you
or
have.
a wallet.
I guess you have switched the definitions.
Yeah, exactly. So externally owned
Too
accounts is
much
that.
material today to digest, sir. Very hard to understand, please, sir.
I'm trying to go as much slow as I can so that I am, you see, this is the basic example, and I'm taking too much time to explain you guys. Okay, so externally owned account is whenever you wanted to have an address for your Ethereum currency, so you will have I can have an externally owned account, and on that account I can store the Ethereum, I can send the Ethereum, I can give that address to someone so they can send me Ethereum. Whenever you deploy a smart contract into the Ethereum blockchain, each smart contract has an address as well. So that address can be used to refer that the smart contract, can be used to send funds to that smart contract, can be used by applications. So when our client will be talking to our blockchain, so that client, let's say browser-based application, so our browser-based application talking to the blockchain, that browser-based application will need an address to talk to your smart contract. So that's the address we'll be getting. So whenever we deploy our smart contract, we get this address. But at this moment, Hardhat just created the temporary blockchain, runs the contract, deployed the contract, and kills the blockchain, and you have the address. So it just, you can see how things are working. If deployment is successful, compilation is done, and everything. So it will just be the local testing. It will not be doing anything. Another option is, what you can do is yeah, let me create another command prompt, and I'll call npx hardhat node. What it will do, it will create a blockchain. It will keep running until you does not exit the terminal. So you have a running blockchain for yourself, and it has a 20 Ethereum account. Each Ethereum has 10,000 ETH. So for at least in your local blockchain, you are the quite rich. Okay, so it keeps running. Now what I can do is I'll go to this interface, this terminal, and what I'll do is I'll pass network command, network option, and I'll say localhost. So previously when I run it, it just created a temporary blockchain, deployed it, and gave me address and destroyed that blockchain. Now what I did is I created a local blockchain, and you see it was difficult to do before. To set up your blockchain, local blockchain, you can use the Ganache and everything, and it's quite handy for us that just run the blockchain, do your transactions, do your testing, and then kill it. And it's not permanent. So whenever you kill it, all the data, all the information will be lost. It's not permanent. Okay, so I'll call localhost. You see, I ran this command in the terminal, and the few transactions executed over here, and it's saying that contract deployment, contract address, transaction ID, from who runs the transaction, gas used, and the block. So it's a very first block in our blockchain because it's a local running blockchain, and that's the hash of this blockchain, and this is the logs. So Hardhat given us a functionality where we can run the console logs. So we'll focus on it in upcoming classes. So at this moment we have run our local blockchain, and we have tested it. We have tested with using the test. We have tested using the local blockchain as well. To run or to deploy on any test network like Rankeby or Robston, we need few changes. So well, I'll explain you how we'll be running this application in Typescript. Then maybe might not today, maybe in the next class, I'll show you how we can run this in test networks as well. Okay, so any questions here?
Sir, do we need to make a Genesis block in it or no?
No. That's the beauty, that it just created the everything and giving you the temporary running blockchain, so you can do multiple transactions in multiple steps and then destroy it.
Just so we can
So
connect this local blockchain to MetaMask as well using the localhost
Yes,
RPC.
yes, we can do this. Yes, we can do this.
So what's the difference between greeter.deploy and deployed?
Sorry, what is the
Greeter.deploy. Difference between greeter.deploy and greeter.deployed.
okay. Basically, when you call greeter.deploy, it's actually go to try to deploy on the blockchain. Once it goes to the deployment, it is a transaction. So when the transaction is happening, transaction went to the blockchain. Now this transaction will take time. So what you wanted to do is you wanted to wait until the transaction is done, your contract is being deployed, then come to me so that I can take some actions on it. So that's why we call greeter.deployed. So once it is deployed, so it's await. So once it's deployed, then we'll get the access to the control here, and then we can do whatever we want. Let's say I wanted to see console dot.
So basically deploy returns us a promise and we need to wait for the response now.
I'll say get data, and then I'll call greeter.greet. Now you see, I don't have access to the intelligence of the function, how the function is working, but anyhow. Okay, so let me run this, and I'll run the command again. Okay. Now, yeah, sometimes we forget this. All the functions calls are promises in the Hardhat whenever you call your contract. So greet is a async function. So you have to call the await. So when you call the await, let me call it again. You see what I'm trying to do is I'm trying to get the data from the blockchain. So this is my blockchain which is running, and I'm trying to call the functions for on my blockchain. Let's say I wanted to call greeter.set. So we don't have the intelligence, so I have to copy it, and I wanted to say hello, or some name Muzaffar. Okay, so now I have to call the await. That's basically we are trying to access our code. So at this moment I'm just showing you how we'll be going to. So we set this function, it will return something which we don't want it, but we wanted to wait till this information is changed. So what I'll do is I'll explain all those things once we go in more detail. At this moment I'm just trying to show you guys what is happening. So today's class is just the get hands-on Hardhat so that we can run everything, and then we'll go deep into the detail of everything. Now I'll call the greeter again. Okay, so you see hello Hardhat and then hello Muzaffar. So what is happening is inside the blockchain, you deployed your contract, then you check what's the information in the function, then you update inside the blockchain, you call your contracts function and it updates the block information inside the blockchain, and you're trying to access the new updated information. That's how you will be running these things.
Sir, clarify one thing. When we compile the Solidity code, there will be return code in the TypeScript.
They will
return the code in TypeScript.
No, they create types for us so that we can just call the types. I'll show you. I guess we have time, always. We have time, right?
Sir.
Yes, sir. It's okay. So that's our first step. So first step was to run the Hardhat. What you need to do to running this application and how you will be setting up everything. The second step is using Typescript. So what you can do to set up a Typescript.
So basically, I wanted to know that when we write code in Java in plain text editor, and after the compilation, they will give you a Java file. And
yes.
Also on the call of Java, they will show the results. Basically, I wanted to know when we compile the code of Solidity, they will return in TypeScript or some sort of the Solidity
no.
forms.
When you compile code in Solidity, they generates the bytecode and the API.
Bytecode in Solidity.
Bytecode is not in Solidity. Bytecode is an intermediate language which is not Solidity, which is not machine language, which is another language which is called bytecode. It is an intermediate language. If you have given me example of Java, so when you compile Java, sorry.
So I said it's a bit similar to assembly language.
Yeah, basically you have given me example about the Java. So when you call the Java C and provide the Java file, what they do, they give you .class file. What does .class file has? It has intermediary code which is bytecode. So exactly there's a similar in the Solidity as well. So if other students are not getting it, don't worry about it at this moment. This is someone who knows the compilation of Java, so that's why to answer him. If anyone else does not understand it, don't worry about it.
Sir,
Okay.
we are changing in
Yes.
JSON file. Kindly, can you open your editor?
Yes.
Yeah, sir, we are changing continuous in simplescript.js. Sir, this file is, how can we link this file is a greater dot to the Solidity file?
Okay, so what you need to understand is Hardhat provides us the complete environment. When you run the Hardhat compile, npx hardhat compile, it compiles the Solidity code, and after compilation, all the bytecodes and ABI are stored here. You see, and in .json file.
There is a default directory structure that this Hardhat follows, and it directly finds the content
Yes,
in the
yes.
folder.
Once it is done, this is available to Hardhat. Now Hardhat's given us a feature where you see you are importing the HRE and you are using the ethers, and it has a function called get contract factory. Based on the name, the word greeter, it goes and try to load the greeter contract from here. You see, so the
So
ABI, it uses the ABI, and bytecode, and then it loads the contract here, and you have this reference over here. Then you call greeter.deploy, because now you have the so they wrap it in some JavaScript variable. I'll show you that as well in the Typescript. So if you give me a time, when I'll run this in Typescript, you will see the types of Typescript with the references.
Sir, basically, what I can understand, when basically Red Hat is giving an environment, and when basically we are not changing in the contract, we are calling the contract from the simple script. Exactly, I'm correct, sir?
Yes, you are right. We are just at this moment we are just calling the contract. To
Thank
change
you.
the contract, I have to explain these are the function, how you'll run the how you'll change the Solidity code. So I have not gone over that yet. At this moment, my focus is so that you can run the environment. This is the professional environment people working on. So when you from the day one, it was easy for me as well to run everything in remix. So we don't have to worry about, we just write the contract code and go on. So it will be very easy. But what we wanted to do is we wanted to have a professional way of working so that we know how things are being done in the professional environment. So that's why we are putting time initially on Hardhat toolkit, the ID development environment. Then once we are equipped with it, we'll focus completely on the Solidity. Okay, so now the step 2 is step 01. That was step 00. Step 01 is to set up your code in Typescript. So for that, all those steps we have done up till now, then what you have to do is you have to this is the link we have to follow. Just a moment. Okay, so they gives us completely detail how you can set up your application in Typescript if you wanted to do it manually. So what you have to do is what you need to understand is these things are being built with components, with things. So you have to know that what these things are. After that, I'll just show you one command. It will just generate the Typescript structure and everything will be there, and you don't have to worry about it. So npm install devset, you need to install the ts node Typescript, then npm install all these libraries. Then you have to rename your Hardhat config to ts. If you are going to use this project and trying to do this, so you have to rename it. Then you have to change, because it's required you, when you move to the TypeScript, you have to move to the import style of command of TypeScript. You have to update the plugin and everything. Then you have to install the type change of the types for Hardhat and Ethers. Then you have to add the tsconfig file, then run compile and everything. So I'm not going to do all these steps one by one, because these can be followed here and then article. So you will be able to write the TypeScript based code. What I'll do is I'll go to recording. Okay, so what I'll do is I'll call demo. So hello 2, and inside it, what I'll do is I'll call npm init again. So, okay, so it's done. I'll call npm install Hardhat. If we'll follow this, then the structure of TypeScript, what will be you will have is you will have all the controls in your hand, because you know what you have written and what you have typed. Once you've done this, you will have this kind of a structure in your hand. Let me show, meanwhile it's installing, let me show you what you will have. So if we go for this step 0, just a moment. So what we will have, again, greater.sol will be the same. Script.ts, so we'll have a file in script.ts. Code at this moment is still the same. Test folder, it will be also be the TypeScript file. Hardhat config, it will be also be this TypeScript file. Package.json, and we have the tsconfig file, which is say we wanted to use CommonJS module and interoperability, and what folders we need to include into the compilation. If you run this will be the basic structure of TypeScript project. And what you can do is okay, we have its folder over here. What I can do is I can go to the command prompt terminal and call npm install, because everything is already set up. Hadi, please stop doing this. So what you can do whenever you wanted to set up your repository for your blockchain application, you can come to this repository, which we are trying to develop. And in step 01, you can use this structure, and you will have the your Hardhat application with the basic TypeScript configuration. That's the one. Another one is you can come to the Hardhat, create your application and everything, and then you call npx Hardhat, and it will ask the basic example, pick the TypeScript one. So if you pick the TypeScript one, it will set up the structure with the TypeScript configuration, and it will have a more detailed configuration and everything. So it's more it has more details, but there will be few things related to the linting and everything which might confuse you. So I'll show you both, and then we'll wind up the class so that you have the basic information of how things, what are the things we have, and then from the next class we'll move forward. Okay, so let me clarify again. At this moment, I have set up two repositories. One is from our DeFi modern application Typescript structure, and another one I am trying to set up with the directly with the Hardhat Typescript. It will take time to install everything. So the repository we have set up, you can see all the structure over here. So let me show you the repository which Hardhat will give you in the Typescript. And they want us to install all these things. I'll avoid this at this moment. I'll just open the code structure. Okay, so again, there is a single contract greeter. There is a script file in Typescript. This is what Hardhat has given us. So exactly same what we have given you in our block of our repository. env.example, that's the important part. It needs we need this to deploy our project to testnet or mainnet. Then linting related to the files, so I'm not going into the details of these files. Hardhat config, and there are a few other things related to the configurations. I'll explain these later. So that's what you need to deploy when you want it to deploy on testnet or mainnet. Package.json and the ts config. Okay, so the installation on this project is done. What I can do is I can start npx hardhat compile. Okay. Okay, so generating typings, successfully compilation finished. Now, interesting thing is artifacts are the same, contracts is the same, greeter.json is the same. The difference is, an important part is Typechain folder. In this Typechain folder, we have a folder named factory, and it has a greeter underscore factory.ts. So what they did is they have created a Typescript class and put the ABI into it, and the bytecode as well, and given us few functions which we can call on this contract. And they have given us a greeter type. So factory is to create a contract, and greeter.type is to it's actual the contract instance, but it's in a it's a kind of a what you say, it's we call it in remote method invocation in Java and all other things. At this moment, you can think of it as a shadow. So you'll just calling a JavaScript file. It will eventually internally call to the blockchain. Okay, so now it generates the types. What benefit you have is, what you can do is greeter.factory greeter, and you can see greeter dot Great. Now you have all the IntelliSense you have, and you are running code with the TypeScript. It will import. So the person you were, one of you guys was asking how it's connect to the greeters. So you see, when we call this greeter.contract, it creates the greeter factory class. Inside that, it has an ABI and it gives us a reference, so we can call all the function on it, and then those functions will go to the Ethereum mainnet. Okay, so just to reiterate what we have learned, and then I'll take few questions and then we'll wind up. So first of all, we are using Hardhat as a development environment to create our decentralized application, to use the Ethereum and to build an application with the Ethereum. For that, we have to set up a project. What we did is we try to run this step, and it has given us all the steps how you can set up your application. Why we did these steps individually instead of doing directly the step, the one I showed you with the all the details, because you need to understand what are things inside and what you need to do and how these things are working. If we don't know every detail, we must know at least that what is happening. Okay, so first we did this. Second, what we did is we tried to we looked into the this TypeScript repositories, that how TypeScript is being set up and how functions will be called. And third, I showed you the TypeScript project which we can set up with the Hardhat configuration. It's has lot of details, and it will give you all the functionality and all the basic related to the deployment, testing, and even the networks, so that you can go to the test network and give your option. These are things we have done. Now, if you guys have questions, so we can answer that, and then we'll move to the end of the class.
Sir, so I had a question that would you focus on the front end part of the dApps in this bootcamp, or we would only handle the backend?
Mostly we'll be handling the backend, but definitely I'll have to show you that how you will be calling it, how you will be running it. So for that, I'll be running those in script file.
So you will be
So
only
this,
teaching us the Ether or Web3 library.
yes,
basically.
but if you know this, this is the JavaScript or TypeScript, you can integrate this into the React as well. So we will see during the course, during in maybe in few classes, if we feel that we need to show it, so I can show you how you can integrate it with the React as well. So we'll do that if we
And
need
is
it.
there any kind of project that we would do, so we would have a real world sense of how the
Yes,
things are working?
definitely we'll do this as well.
Sir, can I summarize what we have learned, and then if I am wrong, can you make it correct?
Yes, please, it will be very helpful.
Sir, today we saw Hardhat. Basically, it's an environment for blockchain development, especially for Ethereum. In that, we make smart contracts. Smart contracts are basically built on Solidity, which is language. And with Hardhat, we compile that smart contract and deploy on a local blockchain. Local blockchain, like when we do development, we have local server. So like that, we have local blockchain. We deploy on that, and it also provide JavaScript or TypeScript through which we can interact with the blockchain through ABI or bytecode, which is compiled.
Thank you so much. It was a good explanation. Anyone have any question? No?
Sergio, hello, Sergio, can we swap our minds? You can have mine and I'll have yours.
If it's possible, there are many people whose mind I wanted. So it's always the when you saw someone you wanted something. So you want someone's mind, I want someone's mind. So it's always be like this. So you have to
We are
work hard
not
for
happy
it.
with our own
One,
at all times.
one more thing.
It's always the same.
Will Sarzia be joining us in future in these
Yes,
classes?
yes, definitely. Yes, definitely. Yes, definitely. He was busy in some engagement. He wanted to join, but he might be he's late. So no worries. He'll be with us in future classes.
Finally, Sir Zia is engaged.
Sarzia is
Engaged.
no, it was other kind of engagement. Okay, so anything
Okay,
related to
so
the what we have discussed today?
Sir, can we use Hardhat for NFTs and ERC20 tokens?
For everything.
Thank you, sir.
Sir, can we build a coin on Ethereum, which is proof of stake, or we can do something like that, like staking coins? Can we build on Ethereum because it's a proof of work?
There are two separate concepts. Staking coin and proof of stake are two other things. Proof of stake is the concept a blockchain is running on. So the Ethereum is running on proof of work at this moment. They are trying to move on proof of stake. So at this moment, you cannot create a coin with the proof of stake concept because your blockchain is running on proof of work. The staking coin is something different. When you ask someone to stake coin on your system and you give them rewards or everything, that is something different.
Okay, sir.
and
So, sir,
even if
can we
create
do
the
it
ERC,
with Ethereum now? The staking part of coin.
Yeah, definitely. There are many applications. One of the biggest application you guys must explore the Olympus DAO and Time Wonderland and all other things, sushi and 1inch. I guess 1inch is also doing. So there are many applications which gives you the staking functionality. So you just go to their websites, go to their GitHub, review their code. It will be very helpful.
Sir, will we learn about metaverse also here or no?
This is specifically related to the how we'll be implementing the dApps. If we need to include the metaverse, then it will be the separate sections, either in this or a separate bootcamp. It is not decided yet.
Sir, people who don't know TypeScript will continue or will first need to learn TypeScript?
You don't have to worry about. If you know JavaScript, then you can do it in JavaScript as well. Or why everyone is moving toward the TypeScript is it gives you the typing. So when you press the dot, you have the functions and you can call. So TypeScript is not something different from JavaScript. It gives you the facility to have the typings and you can call the functions with the naming. You know what the functions are and you can easily call them. So you can do it with JavaScript as well. That's not to worry.
and sir,
Thank you,
can
sir.
someone share the details of the bootcamp, the timing and etc.? Because I just
This is your
got it
first.
from the Sazia's post on the Facebook.
Okay, so we'll be having these class every Saturday at 9:30 p.m. Pakistan time.
And sir, for how much long would it continue?
Generally, we try to. It will be the 2 hours, but definitely not every day. Not every week we'll be having the 2 hours. Sometime maybe we get 1.5 hours, or 1 hour, or so our target is to 2 hours.
And so I was asking the time period. I mean, I meant that how much weeks or days. I was asking how
Oh,
many
that's
weekends.
not decided yet. We'll go with the flow. Maybe sometimes, like today, I had the plan to explain the deployment of the Etherscan as well, and there were other things too. I wanted to explain, but we will not able to do it. So that it's not decided that these much of classes will be following.
So the focus is just completion of the boot camp. I see.
Yes. The focus is the
Thank you
technical
so
part,
much.
as long as it takes.
Thank
Are
you.
we going to learn the flash loans as well?
No. Okay, so I think we are good now, and you guys have all the details. Repository has been shared. You have all the details. Must practice, otherwise it will a day lost will always be lost. So next week there'll be few more things which you will not be able to understand, and it will pile up to in 3 or 4 classes. It will be you will be lost. So you must keep your pace with the class, and at least whatever we have discussed here, you must learn and practice, and then it will be easy. We'll try to keep it as simple as possible, but definitely when you work on advanced systems like this, there will be some difficulties. Okay, then
Sir,
I guess we, yes.
Sir, do we do like for the practice from the repository, we do like step 0, 1, 2, 3, 4? How many steps we do in this week for the practice?
As much as you can do, you have to understand it. So if you understand 0, 0, 0, 1, then you move to 0, 2. If you understand it, what it is doing, move to step 0, 3, then move to step 0, 4. But you just not have to clone it and run it. You have to understand it, what is going on inside.
Yes, sir. Thank you, sir.
If you do as much as. Okay, then.
you, sir.
Thank you, guys, and we see you next week. Bye, guys.
Thank you, sir.
Thank you.
Sir. Thank you.